Hey guys, it's Mr. Dugal, and today we're going to talk about the pros and cons of three different graphs that we have come across. And the three graphs that we have here are our histogram, a box and whisker plot on the bottom, and in the middle there we have a stem and leaf plot. And these three graphs are representing the same data set here, and it just displays differently. So all the numbers in the data set are the same. A few terms I want to introduce us to before we get into the positives and negatives of each is the term skewed right. And basically this means data is mostly on the upper half. So that means that most of my data occurs at the high end. I also have skewed left. As you can probably guess, skewed left means that most of my data is on the lower half, or it's on the left side of a graph. Finally, I have what's called evenly distributed, sometimes referred to as equally distributed, and this is what it sounds like, that the data is distributed evenly throughout the graph. This doesn't need to be perfectly evenly distributed, but just in general it doesn't tilt to the left or to the right. An example of this can already be seen in our first graph, and it really can be seen well in our box and whisker graph on the bottom. So with our histogram, what our histogram does extremely well, it's a great visual display to quickly see the main points of a graph, the main idea. So in general, I can look at this and see, okay, we have a data set, range is in the range of the 40s to 79, so 40s to 70s. It looks like that most of my data occurs in the 70 to 79 range. Here it's showing that most of my data is on the right side. This would be an example of skewed right, because the data is angling to the right. If the purple was a little lower, it would be, say the purple was here, that would be an example of more evenly distributed, even though this one's a little higher here. In that case, it would still be evenly distributed. This isn't crazy skewed right, but it is slightly skewed right. An example of very skewed right, just a quick drawing, would be is if we have a histogram and it's going like this. Almost all the data is to the right. Skewed left would be the other direction. All the data is at the beginning. So with a histogram, it's really easy to see if data is skewed right, skewed left, or evenly distributed. The negative for a histogram is that we don't know the individual numbers. So we're given a range of numbers here, but we don't know exactly what the numbers are. In other words, if someone asked me for what the mean was, I would have to say I don't know, because I don't know if in this data set here, if I have 40 or if I have 49. Right? So I wouldn't be able to know what the mean is. I wouldn't know what the mode is. I mean, maybe in the 70 to 79 data set, maybe I have 70, 71, 72, 73, and I don't have any numbers that occur twice. Or maybe I have 75, 75, 75, 75, 75 four times, and it is my mode, but I don't know because I don't know the individual numbers. There is a graph that will show us that, but that's not really what a histogram is out to do. Again, a histogram's positive is that it's a quick, easy display to show the main idea in a snapshot. All right, let's move on to our stem and leaf plot. Our stem and leaf plot does show us each individual number. So this is great if we need to know some of those central tendencies that we talked about, such as mean, median, and mode. We need to calculate. In this case, we can know. So if I look real quick, I can tell my mode because I can see that there are 2 4s in the 50 range, so I have 2 54s. I also have 2 78s, So I know that my mode is 54 and 78. With a histogram, I was guessing. Didn't know if any of my numbers occurred more than once. I could tell my median. I could cross out 2 at a time from each side. Do it again. Do it again. Do it again. I'm left with 65, and my median is 65. So that's the perk, and I could also find my mean and MAD and all that good stuff, but I'm not going to take the time to do that. I just want to illustrate that we do know the individual numbers, so we can find specific data points. So we're going to say can find specific measures. The negative of the stem and leaf plot is, one, it's not nearly as visually as appealing as the others. So not as visually appealing. And I can't just look at it real quick and get as strong of a main idea. As I start to glance at the numbers a little deeper, I get an idea of what's going on, but it doesn't show me a snapshot image like the box and whisker plot or the histogram. I can start to see that it's skewed right. If I really start to think about it, I'll notice that, okay, this line's the biggest. It looks like, it's kind of skewed to the right. But I don't see it as well as I do the histogram. And especially you'll see in a moment that the box and whisker plot really does a good job of displaying that. So let's get into our box and whisker plot. You'll see what I mean about the skewed right. If I look at where the median is in the box, I can tell that it's really far to the right, which means that my data is skewed right. If it were evenly distributed, it would be right there. If it were skewed left, it'd be more over here. In this case, it is skewed right, so that's why it appears over there. The other really nice thing about a box and whisker plot is I know my percentiles real nice and easy. So I know this is my median, this is the 50th percentile, right around 65. Actually, we know it from our stem and leaf plot, we know it is exactly 65. My 75th percentile, slightly above 70. This is my maximum, just short of 80. It's my 25th percentile, or my lower quartile, just above 50. And there's my minimum. So the positives for a box and whisker plot is that it shows my percentages, the quartiles, and is a visual display to see data skewing. So I can really tell which way the data is skewed just by looking at where my median is within the box. The negative here is the same negative as my histogram. I don't know the individual numbers. So I know that, for example, 25% of the data occurs slightly above 50 here, presumably around 51, but I don't know what the exact numbers are here. And that's true throughout the box and whisker plot here. I don't know the exact numbers for any of them. But each different graph has its own positives and negatives and its own purpose. This is just something to keep in mind moving forward as you make graphs. You want to start to think about, what am I trying to display to others? Do I want them to see individual numbers, or do I want them to see a snapshot picture of my data? If I want individual numbers, then I'm probably going to lean towards my stem and leaf plot because it actually shows the individual numbers. If I want people to just see an appealing image that shows things really quickly without showing the individual numbers, I'm probably going to use a histogram. If I want people to see where they fall within a number line, within a percentile range, and I also want to show if the data is leaning to the right or to the left, then I'm probably going to use a box and whisker plot. That's about it in terms of the positive and negatives for my histogram, my stem and leaf plot, and my box and whisker plot. Thanks so much for watching.